So what was the last week topic, last session topic? Functions. Functions we have started, and last time I think we were discussing about the scopes, right? Inner function, outer function, inner, then enclosing scope, local scope, and global scope, right? Okay. So today we'll talk about scopes, how to manipulate the scope, right? We'll also talk about types of functions. What are the different types of functions that we have? Okay, and we'll also talk about scope type function. Debugging will not start today. We can discuss about, yeah, I think these two topics, and if time permits, then we'll go with okay. So now scope. For that we have created one small example last time. I'll go one more level. So inside the inner function, before calling inner one, I'm printing. After calling inner one, also I'm printing. So that you'll understand what is happening, right? Before calling inner, I'm printing. After calling inner, again I'm printing, right? And before calling add, we are printing. After calling add, also we are okay. Now let's see. Let me give the message so that we can differentiate. So this is inside inner 1. This is before inner 1, after inner 1, before inner, after inner, before add, and after add. I think this might be clear, right? It's as simple because everything is local. Every context, every function have its local variable. When the problem will come, when I now what will be the output in line number 12? 400 is not there, so it will be 300, right? It is 300. Immediate parent. No, it's not there even here. Then now, now line number 12 will give next parent 200, right? So if you look at imagine the memory, then global will be there. On top of global there will be add. On top of add there will be inner, and on top of inner there will be inner one. When you are in line number 12, all these function will be there because inner function is still in execution when you are in line number 12. Add function also in execution. Once you execute line number 12 and go to line number 13, then inner one memory will be removed. When you execute line number 15 and come to line number 16, then inner memory will be removed. When you execute line number 18 and come to line number 21, then add memory will be removed. And when you execute line number 21, then everything will be removed. Global memory will be removed. That's how it works, right? Memory first get created and then start getting removed, right? So this becomes 200. Now if I remove even from here, now what will happen? Clear? Now the question is, we know how to play around the local memory, right? Now it will be 100. Everything will be 100, right? If I remove this also, now what will happen? Which line will give error? We'll get the error because A is not there. But which line is going to give the error? Line number 19. Sumit, which line? Start with line number. The program will start from line number 6, right? Line number 6 is a function definition. It will define the function and it will go to line number 19. It will not go inside until you call it. So it goes to line number 19. Line number 19 we are printing A. We don't have A, right? So we'll get, let me restart. We'll get this error in line number 19. Step by step it proceeds, right? Suppose line number 19 I have not written. This is not there. Now where the error will come? So it calls add function. So it goes inside add function. Line number 8 is a function definition it will execute. Then from line number 8 it goes to line number 16, and there I'll be getting the error. Line number 16. Right? If I remove this, line number 16, now where the error will come? So line number 8 is fine. It went to line number 17. From 17 it went inside line number 10. Line number 10, and from line number 10 it goes to line number 13. So now the error will be at line number 13. How it came in the 13? From line number 17. How it came to line number 17? From line number 20. So you get the entire trace back. We call it as a trace back. Now all the traces. Now where the error will come? From line number 10 it goes to line number 14. From line number 14 it goes to line number 12, right? Inner one function. We're calling inner one, right? Line number 12. Step by step, it start going step by step. Wherever it finds that line, whichever line comes first, and if A is not there, it will start breaking. If I fix, if I let's say remove line number 12, or if I include this, now where the error will come? Now line number 12 will give me error or not? It will not give, right? Because there is a local variable, right? So line number 12 is worked fine. So after executing line number 12, it came to line number 15. So line number 15 will give me error or not? Hmm? Why no? That is in the child function, right? Line number 15 is inside inner. Line number 11 is inside inner one. We'll get error in line number 15, right? Because in the inner function memory is not there. A is present in inner one. Inner one is the child, and parent function cannot take anything from the child function. Clear? Now where the error will come? Inner and inner one both have A. So definitely error will not come in inner and inner one. That means it goes to line number 18 now. Right? Because step by step, if I execute line by line, then line number 18 is the print statement which will come before line number 21. Hence line number 18 is giving the error. If I include this also, now which line will give error? Again go step by step. And number 21, right? Because add function has a, so inside add function there will be no error. Inner function has a, so inside inner there will be no error. Inner one also has a. So basically these three functions are able to access a. Right? After add function, when we come out to line number 21, there is no global variable. Right? Any doubts? Simple step by step we have to execute, and there are 2 3 points that you have to keep in mind. First point was that function always creates its own memory. Local memory is more precedence over enclosing, and then global. Right? Once the function is created, memory is created, after the execution, memory will be removed. Right? Program starts from line number 1. Function definition does not execute the function. To execute the function, we have to do a function call. If we remember these 4 points, then looking at the program and predicting or finding out the flow will not be tough. And you should know how the program is running. What is the steps? Then only we'll be able to find out the error, fix the error, or do some kind of enhancement. If I ask you to build some feature on top of it, then you have to understand the existing flow, right? How things are working, where I can put that logic, right? So variable scoping is very important. Now, till now, what we have seen is we can access the local. If I create a equal to 400, it creates a local memory. Okay. I don't want to do that. What I want is I want to update the value globally. Right now, what is happening when I do a equal to 200, it creates a local memory. I don't want to create a local memory. Instead, I want to update the global. But to update the global, again, both have the same name. So if I create a equal to 200, it will create a local memory, right? So in order to point to the global memory context, okay, it works something like this. Let's say this is my global. Okay, then we create function memory, right? On top of it, this is my function, right? Now in order to, if I want to, I have defined a equal to 100 here. I don't want to create if I create a local memory here, then what will happen? Any update that I do inside the function, that will change this part. I don't want to change this, I want to change this. So what we have to do, we have to refer, right? We have to create a reference. This equal to 200 is the reference. It is pointing to equal to 100, right? This will be a reference object. Okay, and this will be a actual object, right? Till now, we are just creating the actual object. We don't know how to create a reference object. Because the time we create the object, it creates in that memory. So I cannot, from function, I cannot update the global variable. From inner one function, I cannot update the add function variable. Right? So to do this, what we have to do here, while defining the memory, you have to make this should be global A. Global is a keyword. So you have to tell that inside the function, do not create a local memory, create a global reference. A reference object which will point to the global memory. Right? So here what we need to do, should be a global A. Now, when it's global A, what will change? Let's remove this completely for now. If it's global A, what will change? Which A? There are three print statements. What will be the output? When I'm in line number 5, it's a it it goes to the global memory. From line number 5, it goes to line number 6. Line number 6 is a function definition. From line number 6, it goes to line number 10. Line number 10 will print 100 or 200? 100 global. Then it goes inside the function. Inside the function, what object we have? Reference object or actual object? Reference object, because it's a global keyword. So global keyword always point to the global variable. Right? And then you are telling a equal to 200. So line number 9 will give me 200. Right? What will be the output in line number 12? Line number 12. What will be the output in line number 12? 100 or 200? This becomes a reference object. It is pointing to a global variable, right? Inside this function. And then you are making 200. So this is a reference. It is pointing to global, which means globally it will change to 200. Right? If I don't give this, then it is local. Outside the function, it will point to the global. With this, I am creating a global reference. I'll remove this one function, otherwise it becomes confusing, right, for understanding. So I'll just take this example. Now what will happen? How many reference objects we have? Two, right? A equal to 200 and A equal to 300. Both are pointing to global. So now tell me what will be the output in line number 16? It will be 100. Line number 13? And line number 13 is inside add function. So we'll get 200. Line number 12? 300. Now after this line number 12, what is the global variable value? 300. So line number 15 will give 300. Line number 18 will give 300. This is how we can update the variable of another score. Because globally it got changed, right? Both are pointing to this. There's only one physical memory, A, one A. Add function and inner function both are pointing to that. So if you change something, it will change there because it is referring to that. This is not containing the value. This is just reference, right? So that's why I'm telling that this is a this memory. This is the reference. So any change you do, it does not contain the value. Value it is taken from here. So it will go and update here. global. Right? So in line number 18, so in line number 12, we updated the value to 300. Now after line number 12, globally is 300. Now, how many reference object we have? One. Which one is that? A equal to 300, right? A equal to 200 is a local variable. Now what will the value in line number 16? 100. Line number 13? Line number 13 is 200, right? Local. Local at line number 12, 300. Line number 15, why line number 15? Local is more preference, right? 200. This is also you have to keep in mind. These 4 points you have to keep in mind, and I'm adding some more features. Local is more preference than enclosing, and then global, and then built-in. Right? So it will be 200. But line number 18 will give me 300. Because in line number 12, globally I have changed to 300, right? Clear? So now we know how to point to local memory. Just create the object, assign the value. We know how to create point to the global memory with the global keyword. How to point to the enclosing memory. Basically, I don't want to create equal to 300 as a physical object, actual object. I want this equal to 300 pointing to 200. So for that, we'll have one more keyword called non-local. Now what will be the output for this? Line number 16 will give 100. Line number 13 will give 200. Line number 12 will give 300. Line number 15, it's a non-local, right? So this is pointing to enclosing scope, which means after line number 11, this became 300. Same, instead of pointing to global, now I'm pointing to enclosing scope. So this will give me 300, and this gives 100. Non-local is simple. Don't get confused. We have global, right? Global A will point to the global memory. Right? So I have this function that add. I have defined equal to 100. I have equal to 200. and then def inner, and this has non-local A equal to 300. Now when I say non-local, this will point to this, right? So this is the reference object. This is the actual object. When I make it global, then this starts pointing to here, right? And when I don't put anything, then this is the local. We have three scope. Either you can be in the local, I don't want to point anywhere. So if you come out of the function, that will be removed. Or you can point to, you can update the fun, parent function object or global object from the function using these keywords, right? Will this work? How many a equal to 100 is a global variable, but inside the function add there is a global reference object, right, which is pointing to global. Inside the inner function, I'm creating the inside the inner function I'm creating the enclosing scope, right? What is the enclosing scope? It is pointing to the parent. But do we have any variable in the add function? Do we have actual object in the add function? No, right? This gives errors. Inner function is telling that I want to point to the add function, but add function is pointing to global. There is no object in the add function. So whenever you are doing a reference, that there should be the physical object. Actual object should be there. It should not be again a reference, right? Clear? These concepts are very important. Yeah, right. Okay, this recording I'll upload. Very important topic. Okay, go through this multiple times and then understand, because if you understand this part, how does the function or how does the program work, how the memory and allocation happens, and how it starts pointing to global scoping, right? Then you can go and learn anything. Then you just need to understand what all, if you go and learn Django, then what kind of features Django has. Base should be strong. So this is the base, fundamentals, right? Now, so we know what are the different, we know what is function, how does it work, memory wise, what are the scopings, how to play around the scopes, right? How to change the scope from one place to from one context to another context, right? The whole idea of function is not to write everything in a single function. The whole idea of function is to break down the code into small multiple functions, so that if there are some piece of code which is being reused, I need not duplicate in multiple places. I can create a function and call the function in both the places, right? Also, when you're creating the function, when you're writing down the program, there are there are 2 points. There are multiple principles, but two principles you should always keep in mind. Dry. Dry stands for do not repeat yourself. That means we should not repeat the code. If repetition is happening, create a function. Okay? Because if you repeat the code, right, you are creating complexity in your program. Tomorrow, if there is an error, I have to fix in all the places wherever I have duplicated, and then we have to verify if there is a small change in the program, small change in the feature, then I have to do the change in all the places. Basically, your maintenance is high, right? So do not repeat the code. And the second is solid principle. Well, this is the advanced concept, but this two part stands for single responsibility and open for change, not modification. So we should always write down the function, the program in a way that it is it contains single responsibility, right? What does single responsibility mean? I should not create one function and put everything in the same function. Like I'm defining I'm defining a function and this function I'm taking the input from the user, and then I'm adding, and then I'm printing. How many responsibilities this function has? How many responsibilities this function has? What are the two responsibilities? Taking the input, summation, and printing. Three functionality. Right? Now, this is going to work fine when I take the input from the user. Now, suppose if I want to take the input from the database, or if I want to take the input from the file, then can I use this function? No. What you will end up doing? Create one more function add, which is taking the input from the database. Let's say I don't want to print the output. I want the output to be used in some other logic, next set of logic. Then also I cannot use this function. So this is specifically when you want to create, when you are taking the input from the user, then only this function will be used, right? So there are different types of function, like we have function with return type and function with parameter, and then there is a default function. This is the default function. The one which we are creating are the default function, right? If these are the default function, how to break down? Now what we can do is we can create a function called, I can take out this two code, create a function called take input. This function will take the input, Now, whenever I want to call take input in subtraction, multiplication, division, I can call the same function. I need not write the logic again and again. So I don't need this here. I can call. But tell me one thing: if these two functions are defined, I am calling add function. This line from here, and we are going to second line, and then we are calling add function. When we are calling add function, it goes inside, and from here it goes inside. Take A and B. When it comes here, can I access A and B? Both are siblings, not parent child. Enclosing scope is not there. So once I come out of this function, this will be clear. Take input function memory will be removed. A and B will not be accessible. So when you have taken out, how to get the data from other function? If it's a parent child, then we can access. But if both are siblings, then how to get the data? So in that case, this function has to return function with a return type. Now when this is returning, it will come back to this point. We have to store it here. So this A and B and this A and B both are different. Both are local. If you are confused, then you can make it X and Y also. Anything. So in take input, we are taking the input, storing to X and Y. We are passing the data that is getting stored into A. And then we can access. So when you are dividing the function, then how to connect data, right? Now, so from here also I can return and not print. I'll just return. Let the outer code decide whether to print or not. But add function is not going to print. Add function will take the input, do the summation, return the output. Still, this function is tightly coupled because I cannot add by taking the input from the database, right? So what I'm thinking, I don't want this here. I'll call this outside. Take it. I'm getting the A and B. Now this A and B have to pass to this function, right? I've divided both the function into different parts. From here I'm taking the input, which I'm getting here. And this I have to pass. Then only both will be connected. So for that, you have to create a parameter. And you have to pass, let's say this is. And again this is returning, right? So we'll be storing here. And then here you can define if you want to print or not. Right? So this is function with a return type, function with a parameter, and the previous one was the default function. Right? Now, if I want to just use add function without taking the input, don't call this. From wherever you are getting the data, pass it to the add function, it will add and it will give you the result. Then you can decide whether you want to print or not. But this function is flexible, right? Wherever you want to add, you can use this, right? So always create a function which is bring specific role, right? Independent, and it should be flexible enough. It should not be very much tightly coupled. Now it's a loosely coupled. You pass any kind of data, it does not matter from where the data is coming. It is returning the output. It does not matter what you do with the output. Add function has done its job. Right? So you can consider this way. We have take input and then we have add. Right? Then we have one global program. This is my global program, right? So what this program does, this is calling take input, returning, and then passing this to add. So when you want the data, ask the function to return. When you want to give the data, it passes a parameter. Clear? Clear? Fine. We'll stop here.